Yes, well, they say that you can't recognize design in the natural world. It all just got here by evolution. There's no evidence for design, and therefore there's no evidence for a designer. Um, and that is actually their real problem. They don't want to recognize a designer, but they certainly can recognize design. So let's look at a couple of examples, or three examples, where the word design just comes out because there's no other options. Now, how about this one? Butterflies shine brighter by design. Um, and this was from one of the news services that we regularly look through. African butterflies have light-emitting wings that share a trick with high-tech light-emitting diodes. That's LEDs. Now, we have these all over the place now. There's been this wonderful revolution in lighting. So that we now have light emitting diodes which use a lot less power and give you a lot more flexibility in terms of the light and color. Now, we didn't make this up, that headline. It's actually the headline that was in the news service that's associated with the journal Nature. And that was their headline, Butterflies Shine Brighter by Design. And it goes on to describe a study of particularly beautiful butterfly that has these very iridescent patches on its wings. And they really are lovely. And the BBC picked this up and said when scientists developed an efficient device for emitting light, they hadn't realized that butterflies had been using the same method for 30 million years. So butterflies beat scientists by 30 million years, that they reckon. And this was a comment made by one of the scientists who actually was involved in this study. The way light is extracted from the butterfly's system, in other words, how light is reflected from these beautiful, bright, shimmering scales that butterflies have. The way light is extracted from the butterfly system is more than an analogy. In other words, it's not just something similar, right? It is all but identical in design to the LED, to the light emitting diode. So in other words, when they looked at the microscopic structure of these beautiful iridescent scales, they found something that looked exactly like a man-made designed light emitting diode. And then and this is what they actually wrote in their scientific paper. This biological system shares many design features, right? Yes, design features with high emission LEDs. So they cannot avoid using the word design. It's just there. But whose design is it? Well, as this comment was actually printed in the New Zealand Herald, it's amazing that butterflies have evolved such sophisticated design features which can so exquisitely manipulate light and color. Nature's design and engineering is truly inspirational. Now, remember that last sentence, right? Nature's design and engineering and inspirational. Because here we are leaving the scientists just say, oh, well, we're just very sort of, we just stick to the facts. But then they come out with statements like this when they're speaking to the general newscast. You know, we're not religious or anything. So let's look at another example. Do you recognize these? Sam or Joseph, do you recognize?
I do. I used to stick those on my nose.
Did you?
Yeah.
Yeah.
Well. I mean, perhaps I should clarify. I believe I'm right in saying they've got something sticky in the middle.
Right.
If you peel off the sides of it, you can stick it on your nose and wear it like a sort of like a horn.
Yeah, they're the sycamore.
No, not the fact I used to like just sellotape these to my face and just walk around. And beautiful.
Helicopter seeds, we used to call them.
Yes, that's right. Yes, they're maple seeds, and they are commonly called helicopter seeds because they do fly in a sort of way. Now you've got two seeds there which are stuck together, and when that dries out and comes off the tree, they're maple maple seeds. As you can see there, there's two stuck together. Those two actually separate, and then they don't just fall straight down off the tree. They actually do rotate like a helicopter, and which means that they have a lot of lift, and so they rotate in the air, and they can fly quite a long way from their parent tree. Now, that's actually quite a good thing, because it means that the seed then lands in a place away from the shade of the parent tree. And so it's got room to grow, and it's got light. So this is a really clever piece of design. And some scientists decided, well, let's have a look at these and see what is generating what they called aerodynamic lift. In other words, what is enabling these seeds to rotate like a helicopter. And if the wind is blowing enough, they can move for a whole kilometre. That's about 5/8 of a mile. So it's quite a long way just by rotating in the air. And so they did this really clever aerodynamic study. They started off by building a 10 times scale model and immersed that in oil and then rotated it on a robotic arm. So there's a lot of clever engineering just involved in doing this test. And what that enabled them to do was to study the flow pattern in this oil. And what it showed was that the leading edge showed a lot of vortices. They're like sort of miniature swirling whirlpools. And they thought, well, maybe this is the key to how these things actually manage to rotate and move in the wind so much. So they then had to test some real seeds. Of course, it's all very well to do it with their clever model. So they did test some real seeds in a wind tunnel, and they confirmed that this rotation movement and the shape of the seeds was generating these leading edge vortices. And this was the title of their paper: Leading Edge Vortices Elevate Lift of Auto-Rotating. So that's the helicopter part in the helicopter seeds, that they rotate by themselves, auto-rotating plant seeds. And they wrote this in their paper: the enhanced aerodynamic performance. In other words, these are just so clever in the way they float in the wind and rotate. The enhanced aerodynamic performance of auto-rotating seeds could inspire the design of more effective auto-rotating vehicles. Now, if they do manage to do that, just think of what was needed in order to even study this, let alone design some more effective auto-rotating vehicles. And the science news reports often ask other scientists to comment on what's been found. And this was one comment that was made: people don't give plants enough credit for smarts. Now, who's smart in this whole system, right? Do we give the credit to the maple seeds or to the maple plant? Well, we don't do that any more than we give the credit for designing the 10 times model and the robot arm that they had to use to build their model. That took a lot of clever engineering. Here it is in miniature, working the same way. And they're saying, oh, well, it was the plant that was smart. I think there's a bit of a problem there, right? So let's move on to another example. How about some inspired mechanical properties? Now, here we have a picture of a couple of rather small and obscure things. We think of design as being something that's big and clever and pretty, but let's look at a couple of obscure examples. Scientists have found the strongest natural material known to humans. This was reported in one of the other regular news services that we look at. So what do you think that might be? What do you think might be the toughest biological material? Just think about what's the hardest substance in your own body.
Is that like enamel or?
Yeah, yes, that's right. Tooth enamel.
Yeah.
Yes.
Yeah.
Yes, that's the hardest substance. So which creature has the hardest teeth? Well, you might think of something like a shark or a crocodile, but in fact, it's this little creature that's in the photo here. That's a limpet. Limpets.
I was going to go for an elephant or something.
Yes, that's right. But anyway, these humble little limpets actually hold the record for the world's toughest teeth. And now we normally associate limpets with, we had the term stick like a limpet because we see them at low tide when they are actually exposed on the rocks, and during low tide, when they are actually exposed, they just do not move, and it's extremely hard to get them off the rocks. So that's where we get that expression from. But when they are covered with water, they do actually move, not very fast, and they graze on the algae that's covering the rocks there. So that they will just sort of cruise around, and they have a little spiky set of teeth that actually grazes on the algae on the rock. Now that means they have to have particularly tough teeth if you're going to make a living out of scraping algae off rocks. And they found in their teeth was this particular mineral called goethite. And if you recognize that name there, yes, it is the same name as the philosopher Goethe. And this is a particularly hard mineral, but it's not just the hardness of the mineral that gives them the toughness to scrape algae off the rock. And so this was the photos from the study of limpet teeth. Now the teeth are all lined up in a long string up the top there as in a structure called a radula, and you can see they're very, very sharp. And once you get down to the microscopic size, you can see they are a mixture of fibers embedded into a matrix. And the scientists who studied this explains limpets need high strength teeth to rasp over rock surfaces and remove algae for feeding when the tide is in. So that's how they survive. We discovered that fibers of goethite are just the right size to make up a resilient composite structure. So notice it's not just the substance that's involved, it's having the right size and having a resilient composite structure. That means the structure is made out of two different substances mixed together, and that's very common in biological things, and it's becoming more common in a lot of modern technology as well, making composite structures. But it requires a lot of design in terms of combining two very, very different substances to get a desired result. And this is what they wrote in their report: limpet teeth made of goethite reinforcing fiber and chitin matrix. So that's the matrix that those fibers are embedded in, right? Highlighting the structural resemblance to a fiber reinforced composite material with an average fiber length of approximately 20 nanometers, which is very, very, very tiny. So that's why you've got these microscopic pictures that they had to use, right? So again, it's the composition that gives these teeth their particular toughness. It's not just the minerals, and the chitin matrix. Chitin is the sort of exoskeleton that you find in a lot of crustaceans. But the mixture gives you a much better, a much tougher substance. And they went on to say this considerable tensile strength, that tensile means the ability to resist being torn apart. The tensile strength of limpet teeth is attributed to high mineral volume fraction of reinforcing goethite nanofibers. Okay, so you've heard of nanotechnology, right? That's looking at technology down at the actual molecular level. With diameters below a defect control critical size. Now get this at the end here, suggesting that natural design, again, they cannot avoid using that word, because when you see substances that are so well organized, and when they're put together, they make a substance that has properties that the individual substances don't have until they're put together. So natural design in limpet teeth is optimized towards theoretical strength limits. So this, they are admitting, this has been designed to the limits, these limpet teeth. And this was a comment that one of the researchers made again to the science news sites. Nature is a wonderful source of inspiration for structures that have excellent mechanical properties. Now, again, notice how they say, oh, you know, we're just cold, hard facts, but now they're talking about inspiration. When really they should be worshipping the Creator who made the heaven and the earth and all that is in them. And then they went on to say, well, all the things we observe around us, such as trees and the shells of sea creatures and limpet teeth studied in this work, have evolved to be effective in what they do. So in one stage, they're saying, oh, these are just magnificent. They're designed so well. And then they're saying, oh, well, it all happened by evolution. So it doesn't make, they're being quite inconsistent. So they should be worshipping the Creator, but that's the very thing that they're trying to avoid, even though they cannot avoid seeing actual design.